Picture this for a second. What if your static SCCM task sequences, or those massive, intricate PowerShell scripts you maintain, could suddenly, well, reason dynamically? What if, instead of just failing on some predictable error and halting a deployment completely, your script could actually analyze the error, read the logs, and fix the environment all by itself? Welcome to today's Explainer, where we're breaking down a really fascinating engineering report from Anthropic on how to actually build these effective AI agents. We're going to bridge that gap between traditional IT infrastructure automation and the absolute bleeding edge of AI orchestration.
Okay, let's dive into this. Here is our technical runbook for today. We'll be looking at the new automation paradigm, contrasting workflows versus autonomous agents, unpacking 5 really cool composable patterns, discussing how to scale to full autonomy, and finally, we'll wrap up with 3 strict rules for production.
All right, part 1, the new automation paradigm, or how we finally escaped the limits of rigid scripts.
Moving right along to part 2, workflows versus autonomous agents, getting into the core distinction here. So, before we actually start building, we've got to define our terms. Now, we've all seen the massive hype around AI, and honestly, it's so easy to get totally lost in heavy, complex frameworks like Rivet or Vellum. They add these thick, complicated layers of abstraction. But here's the thing. Anthropic's engineers found that the most successful implementations actually avoid all that. Instead, they rely on simple, composable patterns using standard LLM APIs directly. You really only want to add complexity when a simpler setup fails. With that in mind, Anthropic draws a very strict architectural line in the sand. Workflows are basically like your traditional, on-the-rails SCCM task sequences or in-tune remediations. The large language model is just a tool being orchestrated through predefined code paths that you, the engineer, wrote. It's totally predictable. Agents, on the other hand, act a whole lot more like a human Tier 3 troubleshooter. You give it a high-level goal, and the LLM dynamically directs its own processes. It decides which tools to pull from the toolkit, executes them, analyzes the environmental feedback, and then decides what to do next. It's fully in control.
Let's look at part 3, the 5 composable patterns. This is where we really upgrade your IT toolkit.
So, the crucial point is that you don't just jump straight to autonomous agents for everything. Most of the time, you actually just need structured workflows. Anthropic identifies 5 simple patterns you can use to build these systems, and I want to map these directly to the IT and ITSM concepts you're already super familiar with. Pattern number 1 is prompt chaining. It's a sequential pipeline where each LLM call processes the output of the previous one. See that gate check in step 3? That is exactly like stepping through a phased OS deployment. You lay down the image, you pass that output to the driver phase, but before you ever move to application installs, you run a programmatic check, like a WMI query or a script, just to ensure the environment is healthy. Prompt chaining trades a tiny bit of speed for much higher accuracy, because you're breaking a massive task into highly controlled, verifiable steps.
Pattern 2 is routing. This classifies an input and directs it to a specialized task. If you manage a service desk, think of this as your ITSM dispatch rule engine. Imagine a user submits a ticket. Instead of using one massive, highly expensive LLM trying to solve everything under the sun, a routing setup catches the ticket first. If it's just a simple password reset, it routes it to a fast, cost-efficient model like Claude Haiku. But if it's complex network troubleshooting, it routes it to a highly capable model like Claude Sonnet, equipped with specific diagnostic tools. Separation of concerns is absolutely key here.
Okay, pattern 3 is parallelization, because sometimes tasks just don't need to be sequential. We break this down into 2 distinct variations, sectioning and voting. Sectioning is kind of like running independent compliance checks simultaneously. While one LLM instance is analyzing a script for logic errors, another, completely separate instance is running in parallel, strictly checking it for security guardrails. Voting, though, is all about consensus. Think of this like requiring multiple vulnerability flags before halting a major zero-day patch deployment. You run the exact same task through multiple LLM prompts to get a diversity of outputs, ensuring you have extremely high confidence before taking any kind of disruptive action.
Pattern 4 is the orchestrator workers workflow. Now, this is where it gets incredibly dynamic. You have a central LLM acting as the brain. It receives a complex task, dynamically breaks it down, and delegates it out to worker LLMs. Think of this like an SCCM primary site server delegating completely unpredictable, massive workload distributions to local distribution points. The orchestrator doesn't know in advance exactly how many subtasks there are going to be. It adapts dynamically based on the input, synthesizes all the results from the workers, and then delivers the final package. It's purpose-built for flexibility.
And this brilliantly illustrates our 5th pattern, the evaluator optimizer. This is basically the concept of automated QA. One LLM generates a response or writes a script, and a second, totally separate LLM evaluates it against clear criteria and gives feedback. The first LLM then optimizes its work based on that critique. It's literally a continuous automated code review loop. If you're using AI to write complex PowerShell modules or search through massive Intune telemetry logs, this iterative refinement ensures the output is polished and reliable before a human ever even lays eyes on it.
All right, part 4, scaling to autonomous agents, taking the training wheels off.
So we've covered predictable workflows, but what actually happens when you take those training wheels off? As these patterns mature in your environment, you are inevitably going to hit problems where you simply cannot hard code the steps. And that is where true autonomous agents step in. Use autonomous agents for open-ended problems where the required number of steps is totally unpredictable. A really great example from Anthropic's own engineering team is resolving SWE bench tasks, basically complex software engineering bugs. An agent is given a bug report. It has to independently search the code base, read files, write code, and run automated tests to gather ground truth from its environment, and then iterate based on those test failures. It operates for many, many turns without any human intervention. Use this when you really need to scale problem-solving in trusted environments.
But look, autonomy comes with some serious caveats. Autonomous agents mean higher computational costs, and, crucially, the potential for compounding errors. I mean, if an agent goes down the wrong troubleshooting path in a production infrastructure environment, it could cause a massive outage. So, Anthropic strongly recommends extensive testing in strictly sandbox data centers with aggressive guardrails before you ever let an agent touch a live server.
Which brings us to part 5, 3 rules for production, deploying this to your data center. Let's move to and see how this builds out into a deployment strategy. You've built your agentic system, you're ready to deploy. What did Anthropic learn from deploying these systems with dozens of enterprise customers? Well, they boiled their learnings down to 3 non-negotiable rules. First, maintain simplicity in your agent's design. Don't build a massive autonomous agent if a simple chained workflow will do the job. Second, prioritize transparency. Force the LLM to explicitly write out its planning steps so your engineers can audit its thought process right there in the logs. And third, carefully craft your agent-computer interface, or ACI. This last one is so critical that we really need to look at it closer. This quote from the report is an absolute game changer. Think about it. We spend thousands of hours designing graphical user interfaces for humans. Well, the ACI, the Agent-Computer Interface, is literally the new GUI for AI. When you provide an API or a tool to an LLM, is it obviously clear how to use it? You need to treat tool documentation exactly like writing a flawless, highly detailed doc string for a junior sysadmin on your team. Provide the agent with clear parameters, explicit edge cases, and concrete examples of how to use the tool correctly. Because if the tool is confusing to a human, it's going to be confusing to the agent.
Anthropic shares this amazing, super practical tip for ACI, Poka Yoke Your Tools. It's a lean manufacturing term that basically means mistake-proofing. For example, when their engineering agent was navigating file systems, they found it kept making mistakes with relative file paths once it moved out of a root directory. It was getting lost. Their solution? They Poka-yoked the tool by changing the code to force the agent to always use absolute file paths. Once they made it harder for the model to make a mistake, it executed flawlessly. You have to engineer the environment to protect the agent from itself.
Which brings us to our final thought. We are rapidly transitioning from an era where IT automation simply executes our commands blindly to an era where our tools can autonomously reason through complex environmental failures. By understanding workflows versus agents and mastering these 5 composable patterns, you can start building that future today. But I want to leave you with this question to consider. What happens to your day-to-day IT operations, your security postures, and your infrastructure design when your scripts literally start thinking for themselves? Thank you for joining me on this explainer, and I highly encourage you to look at your current tool sets and ask yourself, which of these could be upgraded with just a little bit of reasoning?